lesson 52. It is on chemical mixtures. And the way that the book teaches it is some mixture is poured in and another solution is dumped in to result in this other solution, a third solution. But really what we're doing is we're combining or mixing different concentrates of the same solution at this point. For example, we're taking a solution that is of iodine or salt or whatever it is, that may be a 20% concentrate, adding a solution that has a 50% concentrate to yield a solution that is 30% concentrate. So what we have is we have their concentration and we have the amount of each solution. So what you will do is you'll take, if it's a 20% solution, you'll take that percent times the amount of the solution, and this is how I indicate the solution. You add it to 0.5, which is the concentration, times the amount of that solution to equal whatever we want, the 0.3 times the solution that is 30. Realizing that what this total is the S20 plus the S50. That's all we'll have, because it's just a weight, okay? An amount. All right, so let's look at example problem 50-1 on page 226. It says a druggist has one solution that is 10% iodine. So we have iodine that is 10% and another that is 50% iodine. So we have iodine that is 50. How much of each should the druggist use to get 100 milliliters? So we're going to end up with 100 milliliters of a concentrate that is 20%. Okay? All right. So we know two things. The first thing I can say is that the amount of the iodine 10 plus the amount of the iodine 50 has got to equal 100 milliliters. All right. We also know that if I take the 0.10, that concentrate times the amount of iodine 10 I have plus the concentrate times the amount of iodine 50 I have, it will yield this amount, the 100 milliliters, times the concentrate of 0.2. So I am going to solve for either iodine 10 or iodine 50. And I'll erase this. And I can substitute it in this equation and solve for the other. So we'll say that, let's say the iodine 10 is 100 milliliters minus the amount of iodine 50 we have. So if I substitute this in for the iodine 10, I have 0.1 times 100 minus how much iodine 50 I have, plus 0.5 times the iodine 50 equals, and I can go ahead and multiply 0.2 times 100, and that's 20. I distribute my 0.1, and I have 10, that's 0.1 times 100, minus 0.1 of the iodine 50, plus 0.5 times the iodine 50 equals 20. Move my 10 to the other side. TQ says, excuse me. And my 10s eliminate. And I combine my I-50s. And I'm left with 0.4 iodine 50 equals 10. Divide by 0.4. And the amount, oh, that should have been 50. The amount of iodine 50 I have is 25 milliliters. milliliters. If I have that much in the iodine 50 and I end up with a total of 100, then for the iodine 10, it has to be 75 milliliters. Okay, fairly straightforward. You're simply going to have the amount of one substance plus the amount of the other substance or concentrate is the whole amount, the whole weight, and you're going to have your percent times the amount equals the total. Let's go ahead and work 52-2. Example problem 52-2. All right. It says a chemist has a solution that is 10% salt. So salt at 10% and water and 90% water. Okay, that's the same solution. 10% salt, 90% water. And another solution that is only 2% salt. So we have another solution that's 2%. How many milliliters of each should the chemist, so we're going to add those solutions, use to make 1,400 milliliters, and this represents salt at 6%, okay? So I can solve for one of these, and I'm going to solve for salt 10 equals 1,400 minus salt at 2%, okay? And I can plug it in because I have the 10% times the salt of 10, which is this, the 1,400 minus the salt at 2% plus 2% times the salt at 2% equals the 1,400 milliliters, and I want to end up with the salt at 6% times 0.06. All right, so distributing my 1.1, I have 140 minus 0.1 S2 plus 0.02 S2 equals, this is 84. Okay, I subtract my 140 on each side, and I can combine my 0.1, negative 0.1, and my positive 0.02, and I end up with negative 0.08 S2 equals, and this is a negative, 56. Divide by negative 0.08, negative 0.08, and the number of the amount of salt at 2% I should add is 700 milliliters. If I end up with 1,400, then the amount of salt at 10% I should add is, it needs to total 1,400, so that too is 700 milliliters. So I work these a little different from the book. I prefer this over dumped in and poured in because I know what each of my variables stands for. See you Wednesday.